This is our section 1.8. If you notice at the top of the notes it says 1.5. It's because I'm using the notes from the book last year. I like these notes better than the ones from this year. So that's what we're going with. So just cross that out. Don't be like, this isn't 1.5. It isn't. It says 1.8. Okay? We're talking about combinations of functions. You guys saw this in Algebra 2. You may not have seen it a lot. You may not remember it, that sort of thing. If you don't, if I say, oh, you guys have seen this before, and you're like, oh my gosh, I hate when she says that, I don't remember. That's okay. That's why I'm going through it again, because I know a lot of you don't remember. But it should be a little familiar to you. Today we're going to talk about combining functions using addition, subtraction, multiplication, and division. Tomorrow we're going to talk about compositions of functions when we had like this. Like f of g of x, where you took the g function and plugged it into the f and then simplified. It's a little more involved, nothing too crazy, but it's just a little more involved. So let's look here just to remind ourselves. Guys, if you're asked to find the sum of two functions, sum means to do what? To add. When all you're asked to do is find the sum of two functions, you literally are just combining like terms. That's it. All right, and we're going to talk about leaving something as a function of x versus leaving or evaluating. When we are dividing, why did I say dividing? When we are subtracting, we're literally finding the difference is subtracting. That's it. What do I have to do here before I can subtract? What's my polynomial rule?
Distribute.
Very good. I have to distribute the negative, which in a sense is just going to change all the signs behind it. Good. When I see the word product, guys, the product just means to do what? Multiply. That's it. And then when I see this, the quotient, I have to divide. All right, now with division, there's a little tiny bit of extra work that we're going to have to do. Because when we divide, right, when we find the quotient, when we have a denominator, the denominator can never be what?
0.
Correct. The denominator can never, ever, ever be 0. Cannot be 0. So in a case, we're going to have to find restrictions. There is not going to be a case, well, there might be, but we're going to find where x cannot equal a number, because if it does equal that number, it's going to make your denominator 0. So I'll do an example of each one of these so you guys can see. Talk about one sec. So look, here's a little chart that's good to look at. And the reason that this is a good way to look at is because there's two ways that you can be asked these questions. Notice how these are written differently. They mean the same thing. Do you see how here f plus g, and here it's f of x plus g of x. The first one says f plus g of x. The second one says f of x plus g of x. They both mean the same thing. You're adding the two functions. Same thing here. This is just written a little differently. F minus g of x or f of x minus g of x. Same thing. Does everybody see that? Yes or no?
Yeah.
Okay, so let's look at, usually it's better when you go through examples. This is two questions in one. This first example says, given f and g, find f plus g of x, then evaluate. Guys, when they ask you the question, find f plus g of x, this is answering in terms of x. That means your answer should have x's in it. You're not going to get a numerical answer. So this is how I want you to show me your work. You're going to say f plus g of x equals, what's my f function? 2x plus 1. I always write everything in parentheses on that first step. Plus x squared plus 2x minus 1. Questions on where I got that information from? We okay? All right, now if I'm combining like terms, guys, there's a plus sign in here. Do I have to distribute any negatives? Do I have to look at anything in any sort of way? No. So all you're doing is combining like terms. The highest exponent I see is x squared. Is there anything else that has an x squared?
No.
So I have x squared. I have a positive 2x here and a positive 2x here. What does that give me?
4x.
Plus 4x. Good. Got that taken care of, that taken care of, that taken care of. Now I have a positive one and a negative one. What happens?
Cancel 0.
They cancel out. So your answer here would be f plus g of x equals x squared plus 4x. They asked you to leave it in terms of x. They're not asking you to solve any sort of thing. They're just asking you to combine them. That's it. Some of you are going to say, can I write it as x times x plus 4? Right, you factored out the x. If you want to, that's fine. Really and truly, this is all I need to see is that you combine the two functions. That's it. Now, the second part says evaluate where x is 2. So in this case, guys, you're still adding the two functions, right? F plus g, but you don't want it in terms of x. What are you going to plug in for the x? What'd they tell you to?
2.
Where x is 2. So your function is x squared plus 4x. When you combine those two, you got x squared plus 4x. Now I'm going to take 2 and plug it in everywhere I see an x. So 2 squared is 4, and 4 times 2 is 8, correct? You guys with me?
Yep. Yes.
So your answer to this one would be f plus g of 2. What you're saying is when I plug 2 into this, I get 12. Questions? What I want you guys to take from this is when they have an x here at the end, that means leave your answer in terms of x. You want your answer to have x's in it. When you have a number, you're actually going to get a numerical answer. Now, some of you are going to say, well, can I plug 2 in at the beginning? Okay, if you want to plug 2 in at the beginning and then add, okay, fine. But this question is asking you to find f plus g of x, so in terms of x, and then evaluate. They're asking you to do two things. They're not just asking you to find out when x is 2, okay? Everybody okay with that?
Yeah.
Okay,
Yeah.
talk to me. All right, number 2. What's number 2 asking me to do?
Subtract.
Subtract. Guys, in subtraction, same answer or different?
Different.
How are they different?
Because one's 5, one's negative.
Correct. There's a huge difference, ladies and gents, between a positive number and a negative. So when you are subtracting, order matters. So the first thing I'm doing is f minus g of x. That means my answer should be a numerical number when I get my answer, or it should have x's in it. X's in it. So take the f function. My f function is 2x plus 1 minus the g function, x squared, plus 2x minus 1. All right, so now I just go through it. I just start randomly combining like terms.
No, you distribute.
Good. You have to distribute that negative first. If you guys don't do that, your answer is all going to be wrong. So 2x plus 1 stays up front. When I distribute, I get negative x squared minus 2x plus 1. Remember, if you skip that step, if you forget that step, everything's going to be wrong. So make sure you pay attention. And then now we combine like terms. What's the first exponent, the biggest one that I see that I'm going to start off with?
Negative x squared.
Okay, good. It's going to be negative x squared. Fantastic. That sign goes with it. So I have negative x squared, positive 2x, and a negative 2x.
Cancel.
Cancel out. Positive 1 and a positive 1.
Plus 2. Positive 2.
Plus 2. So here is my answer for f minus g of x. I kept it in terms of x. That means I want x's in my answer. So now when I evaluate, I'm going to say, okay, now I have f minus g of 2. They want me to plug in 2. So I have minus 2 goes in parentheses, plus 2. Now, my last pre-calc. Guys, what do I do first? Do I multiply negative 2 or 2 by this negative sign, or do I square first? You square first. This becomes negative, and 2 squared is 4. If the negative was inside the parentheses, then I agree, yes, it would be 4, but it's not. It's outside. So I have negative 4 plus 2, which gives me what?
Negative 2.
So f minus g of 2 equals negative 2. Since I'm evaluating with a numerical number, then I should get a number as an answer. Questions? Everybody okay? Is this terribly difficult right now?
No.
Okay, good. You guys doing good.
Not visible.
Okay, let's go to the next one. Find the product. Well, what does product mean to do?
So multiply.
Multiply. So I have f times g of x. So I take my f function, which is x squared. Whoops. And then I have my g function, which is x minus 3, and I multiply. X squared times x is x cubed. X squared times negative 3, negative 3x squared. So f of g of x is just that. Don't factor out what they have in common, then you get the original problem. Just leave it like it is. Now what do they want me to do? Evaluate where what?
Plug in 4.
Okay, so they want me to evaluate this function, f times g of 4. So I have x cubed minus 3x squared. Well, I have 4 cubed minus 3 times 4 squared. What's 4 cubed? 4 times 4 is?
60.
Times 4 is?
64.
Good, 64. Minus 3 times 16?
48.
So 64 minus 48
16.
is 16. So your answer would be f of g of 4. This is a 4. Oh, my handwriting is so bad. 4 equals 16.
It's way better than my handwriting.
Yeah, for me too.
Well, thank you. I appreciate it. Some of you turn in stuff and I'm like, oh my gosh, this is beautiful. Handle this. What are they asking me to do here in this question?
Put the root of x over the root of 4 minus x squared.
Yep, we're dividing. Guys, remember, order matters here. 6 divided by 2 and 2 divided by 6. Same answers?
No, 6
No.
over 2 is 3 and 2 over 6 is 1/3.
Correct. So order matters. If it says f divided by g, put f on top and g on the bottom. So you have f divided by g of x. Well, my f function is square root of x, and my g function is 4 minus x squared. Now, in my last period, they're like, wait, you can't have a radical on the bottom. Guys, you don't have to rationalize. They're not asking you to solve this. All they're asking you to do is combine them. So now I look at this. Is there anything in the numerator and the denominator that is exactly the same that I can cancel out?
The x?
Are the x's exactly the same? No,
No,
it has to be
no.
exactly the same. So there is your f of g of x.
Why can't you cancel out the radical?
Because the two radicals are different. They have to. It would have to be the exact same. It would have to be square root of x on top and square root of x on the bottom. These two values are different.
So, would you be able to root the bottom and make it 2 minus x?
You don't. They're not asking you to solve. They're not asking you to make this smaller or condense or anything. They're just asking you to combine them. So you would just leave it. Unless if there was like a 2 here and a 2 here and you could cross them out, something like that. But it has to be exactly the same on the top and the bottom. Okay? You guys with me?
Yeah.
Okay. Now, when you have division, okay, now if they gave you a number, they said to plug in 9 or 2 or, whatever, you would then plug in. But they ask you to find the domain. Domain is what values?
X value.
Okay, domain is our x values, okay? What can the denominator never, ever, ever be?
0.
Can't be 0. So you guys have been taught algebraically to say, okay, 4 minus x squared, and it has to be, since it's under a radical, it has to be greater than or equal to 0 generally. But since it's a denominator, it just has to be greater than. It can't be equal to. So you guys would solve this, and you would square both sides. And you'd have 4 minus x squared greater than 0, right? Okay, back to focus, right? So then we would, what? Subtract 4 from both sides. Negative x squared greater than negative 4. And then we'd have to divide both sides by negative 1, right? So x squared less center to 4. And then we would take the square root. I'm going through this quickly because you guys don't have to write this down. When I take the square root, and then I have x is less than plus or minus 2. What does that even mean? X is less than or greater than plus or minus, like what does that even mean? So when you have a denominator, the best thing to do is to set it equal to 0, okay? We know that this is a parabola because it's x squared. We know that it's an inequality because it has to be greater than 0. But just for solving purposes, let's just pretend you can do this every time. Set it equal to 0 or not equal to. Okay, so I'm going to square both sides. And we'll do a bunch of these in the next couple days, don't worry. So I have 4 minus x squared cannot be 0 because the denominator cannot be 0. So I'm going to add x squared to both sides, save myself a step. Agreed? You guys with me?
Wait, why did you take off the radical?
Because I squared both sides.
Oh, yeah.
So then I have x squared equals 4, square root both sides, x equals plus or minus 2. All right, what you just found there were like your critical points. I call them key points. We know this is a parabola, we know the shape of it, all that good stuff, but these are our key points. So what I want you guys to do in this situation is draw yourself a little number line. And we're going to test.
Miss Meadows,
Uh-huh.
I'm confused.
Okay, which part?
Why does it have like an equal, like it can't equal 0, and then after it's like it can't equal whatever like it turns out to be?
On which part? Because your denominator can never be 0, correct? So I have an expression in my denominator. So I have to figure out what number will make my denominator 0. It's not just 0. You can plug 0 in here. 4 minus 0 is 0. Square root of 4 is 2. So you have to figure out what number will make it 0. If I plug in positive 2 or negative 2, my denominator will become 0. So then we can't use that. But in this case, it's a parabola, so it has sides. It's got a middle, it's got sides on either side. So you find your critical points. We call these key points. All right, and then you're just going to test some points. Pick any point to the left of negative 2. Any number in the world you want to. Anything over here?
Negative 1.
Nope, negative 1's over here.
Negative 3.
Okay, negative 6. Let's do negative 6. Somebody else do negative 3. Okay, let's check negative 6. If I plug, all right, if I take my denominator, square root of 4 minus x squared, and I'm going to evaluate this where x equals negative 6. Everybody with me? So I go, okay, square root 4 minus negative 6 squared. 4 minus, what's negative 6 squared?
36.
So I get the square root of negative 32. Is that going to give me a real answer?
No.
No. So anything on this side of negative 2 will not work. So let's pick something in the middle, in between 2 and negative 2.
1.
Positive 1? Okay. So I'm going to say x equals positive 1. So I have the square root of 4 minus 1 squared. Okay? 4 minus, I forgot square root. What is 1 squared?
1.
So I have 4 minus 1, so I get the square root of 3. Is that a real answer?
Yeah.
Yeah. Is it a good one? Like, is it a nice, pretty whole number that we like to use?
No.
No, but it's a real number, so anything in this area will work. It's good. So now let's pick something on the other side, to the right of 2. Okay, 4. I'm going to evaluate where x equals 4. So I'm going to say, okay, 4 minus 4 squared. What's 4 squared?
16.
Okay, so then 4 minus 16 would be Negative 12?
Uh-huh.
Is that a real answer? So where, guys, on a number line are the only numbers that'll work here?
Between the -2 and +2.
So your domain would be from -2 to +2. And what would your notation be on either side?
Parentheses.
Why? Very good. How come?
Because you don't include the 2's.
We can't include the 2's. Because what happens when my when I use -2 and +2? What happens? My denominator becomes what?
I don't know.
You put 0.
It becomes 0. And then it's no bueno. So when we graph these, when you guys find the domain, when you have a parabola and you have your critical points, a number here and a number here, there's always two different possibilities. It's either the stuff in the middle, which is called an intersection, or your plug-in points and the stuff on the outside works. Does anybody know what that's called? When it's something and something else?
Union?
Yeah, good. A union. Good. Now, those are the ones that are the most difficult. I understand that. And we'll work on those. But when you're combining, you're literally just using like your rules of polynomials to add, subtract, multiply, and divide. But that's 1.8 section 1. We'll do section 2 tomorrow. I'll upload this video in just a minute.